Okay, good evening. Welcome to
Math number 653.
Math 653. So yesterday we were looking at your game where you were rolling 3 10-sided dice,
Yeah.
looking at the number, and then repeating that process and seeing which number got to 40. Appeared 40 times first.
Yeah.
And which number did you get?
I got 15.
15 got to 40 first. So according to what we learned on Mathematica yesterday, the number 15 should appear as a sum 73 out of 1,000 times.
All right.
And on this one down here, 16 and 17 were the most common ones, which were 3 out of 40, which is, do you know what that is out of 1,000? 3 out of 40?
Let's see, I think that's 75?
Good. 75 out of 1,000. So just slightly more likely, right?
Yeah.
Overnight I ran a simulation that repeated your process 1,000,000 times.
All right.
And maybe I can zoom in on it a little bit. So this was the number 16 and 17. They both appeared just about 205,000 times, and 206,000 times. 15 and 18, 160,000 times. 14 and 19, about 93,000 times.
Great.
13, 34,000 times. 20, 34,000 times. 12, about 6,000 times. 11, 243 times. Same with 22. 10 only appeared 3 times.
I guess it's not very likely that you're going to get 10. It's your number that reaches first.
Yeah. But the one thing I wanted to show you about this graph is this graph falls off really fast.
Yeah.
Like 16 and 17 are much more likely than 15 and 18.
Yeah.
And then 14 and 19 are less than half the time.
Yeah.
But if we go back down here to see how often they appeared, 16 and 17 appeared 75 out of 1,000 times.
Yeah.
But like 14 and 19, which were less than half, were 69 out of 1,000. Not that much less.
Well, if you amplify that, you're going to 1,000,000. It's 1,000. It's 1,000 times the difference.
Uh-huh. So that's what I wanted to ask you. Why do you think this falls off so quickly? Why do you think 16 and 17 reach 40 times the fastest? Most fastest. And then it falls off really fast.
Well, I think it's partially relates to the probabilities. Like, the ratio will stay the same if you do more and more of these.
Mm-hmm.
So, and also, the different combinations that you can make sort of relate to that. So the ways you can make the numbers with the dice.
Okay.
Oh, and also, I mean, there's only like 30 numbers, so.
Right.
And this bell curve seems like the shape will appear like a lot. It's gonna be like the standard shape or something like this.
Okay.
So.
But our curve down here was much flatter. This isn't perfect. This was 1,000 times. But you can see it's very flat. Even so, for example, 16 appeared 153 times, and 10 appeared 83 times. So let's call that half the time.
We didn't have any that had like.
Yeah. Well, these were the rolls actually.
Oh.
This was how often 15 appeared as a roll, and 16 appeared as a roll, and 17 appeared as a roll.
All right.
And this graph up here was how often they got
to
40 rolls first. And it's much steeper. It falls off a lot faster.
Well, I guess you'd sort of relate that if you have like a curve like with 1,000 rolls, and it's kind of like not very steep, and you amplify it by a lot, the intervals are going to be a lot bigger.
Interesting.
So that's why.
Okay.
Yeah.
Oh yeah, I thought this was actually really interesting to see, and I wanted to see what you thought of it. So.
Yeah.
Good job.